the number in front of the x are the gradient. Is it positive or negative? Well, the power of the x determines the shape of the graph. So let's see. Power is 1, which means it is a linear graph, which is a straight line graph. If x power 2 is a quadratic graph, you see it's actually a smiley face and a sad face. Well, x power 3 is a cubic graph. So next, I'll call this a special graph. So how does a special graph look like? Special graph looks like this. Whereas x can be a power or x can be behind a ln, which is not a number. So in an exponential graph, it looks like this, where the graph won't intersect the x-intercept, while the ln graph won't intersect the y-intercept. So how does a gradient affect this kind of graph? In a gradient positive graph and a gradient negative graph, as you can see, in each graph are different. So how do I memorize all this, the graph? If the gradient, okay, so the tips is right here. Look, the graph from left to right. If the gradient is positive, the graph going to end up on top of the graph, while the gradient is negative, the graph is going to end up at the bottom of the graph. So let's take an example. A linear graph. In a positive linear graph, it looks from left to right. We look from left to right, the graph goes up. Okay, look at that. It goes up, which means it's end up at the top part of the graph. If you look at the gradient negative graph, if we look from left to right, the graph goes down, which is end up at the bottom of the graph. Same goes to the quadratic graph, cubic graph. It goes up, it goes down. Exponential, which is a special graph, goes up, goes down, goes up, goes down. So this is how I memorize all these graphs. So how do you memorize all these graphs? It depends on you. So right now we are going to discuss about the gradient of the graph, the distance, and how to find all these three from a graph.
Of the line. In mathematics, slope of a line is a number that describes the direction and steepness of the line. It is often denoted by the letter m and can form the equation y is equal to ms plus c. We can also use the formula to find the slope. For example, m is equal to y2 minus y1 divided by s2 minus s1. To calculate the slope of the line, we can also use the different words for the y coordinates and s coordinates. For example, some of the people will call the y coordinates as rise and s coordinates as run. And they use delta notation and call y coordinates as delta y, whereas they will call x coordinates as delta x. Now let's see the example to find the slope. This is one of the example of a straight line which consists of 2 points. One of the points is 3, 4, and another point is negative 2, 0. The slope of a line is going through the point 3, 4, and negative 2, 0 is 4 over 5. Y is 4 over 5, and let's see this formula. The slope is equal to y2 minus y1 divided by s2 minus s1. And x2 is, and y2 is 4, y1 is 0. So y2 minus y1 is 4 minus 0, whereas x2 is 3, s1 is negative 2. So 3 minus negative 2. So it becomes 4 divided by 3 plus 2 and equals to 4 over 5. The example 2 of a straight line which consists of 2 points. One of the points is negative 2, 4, and another one is 3, 2. The slope of the line through the points negative 2, 4, and 3, 2 is negative 2 over 5. This is because by using the slope formula, slope is equal to y2 minus y1 divided by x2 minus x1. And y2 is equal to 4, y1 is equal to 2. So 4 minus 2 divided by x2 is negative 2, s1 is 3. So negative 2 minus 3. So it becomes negative 2 over 5. This is a graph which consists of a straight line and it touches the points 0, 2. The slope of this horizontal line is 0 because any horizontal line has a delta y or rise of 0. Therefore, regardless of what the run is, the fraction representing slope has a 0 in its numerator. Thus, the slope must evaluate to 0. This graph shows that it does not have any rise to it. This is the graph which consists of a vertical line and it touches the points 2, 0. The slope of this vertical line is undefined or infinity because any vertical line has a delta x or run of 0. Whenever 0 is the denominator of the fraction, in this case of the fraction representative, the slope of a line, the fraction is undefined.
I will start about how to to find midpoint of a line for a single line on a graph. To find midpoint, we use this formula, which is m equal to xa plus xb over 2, ya plus yb over 2. So we get the midpoint. This is example on how to find the midpoint. So we use this formula, xa plus xb, ya plus yb over 2. So we assign this negative 3 as a xa, ax as a xb, and y as a ya, negative 1 as a yb. So we use the formula and we calculate. So this is midpoint. So this we get the midpoint. So this is midpoint.
Hi, today I would like to teach how to find distance between 2 points on a line. The distance formula is derived from the Pythagorean theorem. If you want to find the distance between 2 points on a line, first the method is take the coordinates of 2 points you want to find the distance between, which is point 1 you label with x1, y1, and point 2 you label with x2, y2. x1 is the horizontal coordinate along the x-axis of point 1, and x2 is the horizontal coordinate of point 2. y1 is the vertical coordinate along the y-axis of point 1, and y2 is the vertical coordinate of point 2. Method 2. You must know the distance formula to find out the distance between 2 points on a line. The formula finds the length of a line that stretches between 2 points, point 1 and point 2. The linear distance is the square root of the square of the horizontal distance and plus the square of vertical distance between 2 points. More simply put, it is a square root of x2 minus x1 squared plus y2 minus y1 squared. Third method is find horizontal and vertical distance between 2 points. First, subtract y2 minus y1 to find the vertical distance and x2 minus x1 to find the horizontal distance. Don't worry if the subtraction yields negative number, because next step is to square this value, and squaring always results in a positive integer. Then, find the distance along y-axis. For example, 0.32 and 0.78. This means that are 6 units of distance on the y-axis between these 2 points. And then, find the distance along x-axis for the same points, example points. And this means that there are 4 units of distance separating the 2 points on the x-axis. The fourth method is square the both values. This means that you will square the x-axis distance x2 minus x1 square. Then you will separately square the y-axis distance, which is y2 minus y1 square. As example, you got 6, which is the distance of y-axis from the set 3, you got 6, and you square the value, and you got 36 for the distance of y-axis, and x2 minus x1, you got 4 from the set 3, and you square it, you got 16. Method 5, add the square values together, which is x2 minus x1 squared plus y2 minus y1 squared. As example, 16 plus 36. This is from step 4, which is you square both value, and in step 5, you add the both value that you square, which you can get 52. Okay, last but not least, method 6, take the square root of the equation. So this is the final step in this equation. The linear distance between the 2 points is square root of the sum of the square values of the x-axis distance and y-axis distance. 52 we got from step 5. After we add the square values together, we got 52, and we must, in the last step, we must square it to get the distance between 2 points on a line. Approximately we got 7.21. Example question: what is the distance between point 24 and 26.9? We have crossed the 2 points, which is point 1 and point 2. We must know the horizontal distance and vertical distance to find x-axis and y-axis. Okay, in step 2, plug in the side length into the Pythagorean theorem, which is we must find x-axis, which is x2 minus x1. So the point x2 is 26 and the point x1 is 2. So we minus it to find the distance of x-axis, which is 24, which is the horizontal distance. Then y-axis, we must subtract y2 minus y1, which is 9 minus 4. We got 5. This is the vertical distance of y-axis. Then we know how to solve the hypotenuse. We want to find this distance using hypotenuse, which is a squared plus b squared equal to c squared. This is the formula of the theorem for the graph. If you plug the coordinates into the formula, you may arrive at the same solution. This is the formula to find the distance between 2 points on a line. Firstly, you must subtract x-axis, which is 2 minus 26, and y-axis 4 minus 9. So you can find the distance of x-axis and y-axis, which is negative 24 x-axis distance and negative 5 y-axis distance. You don't forget to write the square root, and the next step is you must square both sides separately. Then the next step is add the square values together. Okay, you must add the square values together. Don't forget to write the square root. And the last step is you must square root the answer after you add the square values together, and you got the distance is 24.5. Notice the line colored green that shows the same exact mathematical equation both are above using Pythagorean theorem and formula. You may see this green solution. You get the same mathematical equation.
Possible technology that can be used as teaching aid for single line on a graph. I will use graphic calculator for single line calculate equation for single line on a graph. This is advantageous using graphic calculator. First of all, to reduce the complexity of solving single line on a graph problems. Second one, enough number of solving equation for a single line problem. Okay, for disadvantage using graphic calculator is students find it difficult to solve simple problems about single line on a graph without using calculator. And last one, no skills building while solving single line on a graph problem. Thank you.